In today's lesson, we are going to be looking at linear modeling. So in this unit, and in particular this lesson, we're going to look at different models that we can use for different sets of data or different situations. We're going to look at other ones, but first we're going to start off with one of the simplest ones, linear modeling or linear relationships. So just as a warm-up, going to go through a couple questions, just get you to kind of think. We will be going through other examples with this, so I'm not going to write these down, or just going to kind of give you a couple seconds to kind of think about each one. So what is the independent variable in this situation? So Shelley's electricity costs, we have monthly costs, and energy. So what do you think is the independent variable? Next question, kind of the reverse of that. What is the dependent variable? So it's kind of a 50-50 chance, right? What is the independent? What is the dependent? Actually, why don't we go through and try to answer these anyways? So the independent variable for the first one is the energy. The dependent then, in this one, would be the monthly cost. Describe the relationship between the monthly cost and energy consumed. Well, looking at it as energy consumed goes up, so does the cost. Estimate the cost of 200 kilowatts. So 200 kilowatt hours, again, we have 200, so we can kind of go up, hit our point here, and then go over. So this looks like it'd be $50. So I would roughly estimate $50 for 200 kilowatt hours based on our relationship or our model. How does the cost change each time the consumption goes up by an hour? Well, if we look at each hour, or it goes up not by each hour, by each 100 kilowatts. If we look at each 100 kilowatts, we should be able to see that for every hour, or for every 100 kilowatts, the cost changes by $5. $5 per 100 kilowatt hours. What are suitable units for the rate of change of this relationship? When we're looking at rate of change, this should be a little bit of a review, going back to grade 9. So if we forget, that's okay. Rate of change is another word for slope, multiplier, what our graph is changing by. So in this case, we would look at, it would be the dollars per kilowatt hour. So basically the dependent variable divided by the independent variable. So it's going to tell us how the relationship is changing. And the cost is going to increase by a certain amount for every single kilowatt hour that we use. So what is the rate of change in this specific situation? Well, if it's $5 per 1 kilowatt hour, or per 100, sorry, mistake. So per 100 kilowatt hours, if I want to figure out per 1, I would just do 5 divided by 100, which is $0.05 per kilowatt hour. I could also rewrite it and say 5 cents per kilowatt hour. So what would an equation be that represents this situation? Well, if we remember the equation of a line should be y equals mx plus b. M being my multiplier, my rate of change. So my equation would actually be y equals 0.5 or 0.05 x plus an initial value of 40. Because that's where we're starting. And we will look at those situations in depth a bit more. first, what we're going to do is we are going to look at making graphs by hand. So here we're looking at the time and the fuel remaining in our data table. We want to, again, we're asking the similar questions. So we're asking, what is the independent variable? Well, in this case, the independent variable, independent again is the one that does not rely or is not affected by the other. In this case, our independent variable is time, and we're looking at it in time in hours. Now, we can also tell by the table because usually the first column is your independent, the second column is your dependent. So the dependent variable then in this case is the fuel remaining. So the fuel remaining is dependent on the amount of time spent driving. It's also the second column in our table, so that's again another way we can check. So what are the suitable units for the rate of change of this situation? Well, if we're looking at rate of change, again, rate of change, if you remember back from grade 9, is again the slope, the multiplier. It's essentially a combination or a division of the independent variable divided by the dependent variable. So in this case, or sorry, not the independent, the other way around, the dependent divided by the independent. So in this case, our unit rate would be gallons per hour, or the amount of fuel remaining per time, in this case, gallons per hour. What is the amount of fuel remaining after a given time? What is the rate of change in this specific situation? Well, we want to see how much are we losing per hour. So we're going to look at here, we can look at the first value here, and we can look at this value here. So what is that change? Well, going from 19.5 to 16.3, that's a change of 3.2. So we're going down by 3.2 gallons. And that's a change that happened over 1 hour. A positive one. So in this case, the rate of change is negative 3.2 gallons per hour. Now, how long before the tank runs out of fuel? Now, there's different ways we could do it. We could continue this pattern. We could come up with an equation. Right? If we know the rate of change, we know where we start at, we can figure out, okay, well, how many times does 3.2 go into 19.5? We do some division there. Looks like it's around 6 hours. We could also take those points and then graph them. So we could graph these specific values. So we could start at 19.5 and then go down to 18.7. 18.7. Then we can go down to, at half an hour, 17.9. And then we can go to 17.1. And so on. 16.3 is the next one. We could do that, and then we can continue. We could then draw a straight line that would go through all those points. Again, we're going to roughly estimate it because of the fact that line may not be 100% accurate. Draw a line, and then we could estimate to see when is it going to hit 0 gallons remaining. The other thing you could do, because our graph doesn't quite extend long enough, the other thing we could do is we could come up with an equation. So here, our equation would be y equals minus 3.2x plus 19.5. Again, where we start and where we finish. So in this case, y would be 0. because it runs out of fuel. That means the y value equals 0. And we're trying to find the x value, or the independent. So negative 3.2x plus 19.5. This again works out to then, we move it over, negative 19.5 equals negative 3.2x. This is essentially 19.5 divided by negative 3.2, which will give me an x value, which we did do at the beginning. And we got a value of 6.0 or 6.1 for x. So that means based on the equation, we would run out of fuel after 6.1 hours, or just before 6.1 hours. And again, we could continue our table following that pattern. We could extend our graph and continue that way as well. Different ways that we could reason through it. Now, we could also do this in Desmos. We could also create the table in Desmos and go through that entire process rather than doing it by hand. So again, if we want to do it by Desmos, we can go to desmos.com, selecting graphing calculator. So I'll bring it up here. We can select the graphing calculator, and we're going to be given the option to kind of enter an equation, or if we click this little plus button, we can insert a table. And from here, we can go through and insert all of our values. So we can insert that entire table of values that we had by plugging in our points on each specific part. So again, I'm just going to pause the video so that we can kind of just jump ahead. So with the magic of technology, we now have a completed table. So we can't really see the table on the graph, or we don't see the dots on the graph because, again, the values are a little bit too high for our scale. But if we click on this little magnifying glass down here that says zoom fit, we can click on it, and now we see our points. So our points will give us the actual graph. So we've created our points, essentially what we just did by hand, right? So the points have appeared. Now what also Desmos can do, Desmos can insert an equation or create a line of best fit. So kind of that line that we drew. It will also give us the multiplier and the equation of a line. So we just have to enter in this formula here directly into the line or a box below, so we can see that we've had a line below. So we're just going to type in y1. It'll automatically put it subscript. Then squiggly line or mustache, mx1. And we can see we have a line, but we're at plus b. So now we have our equation of a line. We have the m value, which we can see is negative 3.2, which we had. The b value, or the constant, or the initial value, is 19.5. So again, the same values that we had for our equation over here. Right? So if we don't want to do that by hand, which again, it might be more difficult or more time consuming, we can always use Desmos to come up with that equation. Right? And Desmos will make sure that that equation is correct. So again, different ways to do it. I would definitely, given the opportunity, use the technology because it's a lot easier and a little bit more safe. So linear models. So linear models can be represented by a linear relation in the form y equals mx plus b. So that's that equation of a line that we've talked about. Y represents the dependent variable, or the y value. X represents the independent variable, or the x value. M represents the rate of change, or the slope. And b represents the initial value, or the y-intercept. Right, so again, hopefully this is a review from grade 9. So a linear model shows equal changes over equal intervals. A straight line can be drawn through the points on a graph. So because we can draw a straight line, similar to the one we just saw here, that means it's linear. There's equal changes over equal intervals. That's that rate of change. For every 1 hour, it's always going to decrease by 3.2 gallons. That's going to be consistent over every hour. And the first differences in a table of values are constant. We'll talk a bit more about that in a second. The rate of change for a linear pattern can be used to predict future values. So again, the modeling we do is to create a model so that we can make predictions in the future. Right? If we have a couple data points, we create a line of best fit, we can create a model that we can use to come up with other values or again, make predictions. So if the rate of change is positive, that means that the quantity is going to be increasing. If it's negative, it's decreasing. And if we have a rate of change of 0, that means that the quantity is just constant. It doesn't change, it just stays as is. So let's look at a couple of examples. So Jessica works at a bake shop. She gets paid $10 for her shift and then an extra $2 for every brownie she sells. Well, let's create a table of values. X is going to be the independent, Y is going to be the dependent. So in this case, the independent is the number of brownies. So that's independent, and the dependent is going to be her earnings, we could say. Earnings, salary, whatever you want to say. So her earnings. So if she sells 0 brownies, she makes $10. 1 brownie, $12. 2 brownies, $14. 3 brownies, 16, 4, and 18. So here, this table of values, we can see that our first differences are the same. So our first differences is the difference in, or the change in Y values. So here we go up by 2, up by 2, up by 2, up by 2. So those first differences are all the same. So that when we talk about first differences having a consistent increase, that's what we're referring to, or increase or decrease, or consistent change. This is what we're referring to. The rate of change is the dependent, over the independent, or the Y over X. So in this case, earnings per brownie. So how much does she earn per brownie? Well, in this case, it's $2 per brownie, or per 1 brownie. You could say the rate of change is 2. Now, if we want to come up with an algebraic equation, Y and X are going to stay variables. They represent any number of earnings, or any amount of earnings, and any number of brownies. The M represents the slope or the rate of change, which is 2. So every 1 brownie, we're increasing by 2. And then the B value is our constant, our initial value, our Y-intercept. So in this case, we start at $10. So that would be our equation for this relationship. So we could model Jessica's earnings using this equation. And we could make predictions. So we could predict if she sold 20 brownies, how much would she make? If she wanted to earn $100 in a day, how many brownies would she have to sell? So that's what we can use this equation for. We can also graph it if we really wanted to, just to visually represent it. So 0 brownies is $10, 1 is 12, 14, 16, 18, 20. And again, because it's linear, we do see this kind of straight line pattern, or straight line through those points. So this may have been, or this hopefully was a little bit of review, because you have looked at linear equations before, specifically the y equals mx plus b form, all the way back in grade 9. But if not, if you forgot that, that's okay. So again, the main thing is the characteristics of a linear model or of a linear relationship, understanding how to find the rate of change if we needed to, determining the independent and dependent variables, and then again, you can use Desmos to make predictions by creating lines of best fit, or just even graph the relationship in general.